Hello everyone, my name is Albie Domi, and I'm a rising junior in the College of Arts and Sciences advised by Dr. Chimith Rajapakse at Penn Med. My research focus this past summer was on the automation of 3D segmentation of spine MRI scans using deep learning. Usually, radiologists have to go through the tedious task of manually segmenting each vertebrae in each slice of an image sequence from a patient's scan in order to propose a diagnosis. Being able to automate this long process for the spine alone will boost efficiency in the radiology department, reduce patient waiting times, and inspire the automation of segmentation of other commonly scanned areas of the body, such as head CT scans. We wrote scripts in Python to load and pre-process data and run the model training process with TensorFlow. The first step in our workflow was to create the training data. In order to create the data for 2D segmentation tasks, 2D images must be carefully segmented manually to create a mask for each image. In 3D, whole volumes must be carefully segmented manually to create mask volumes. We manually segmented over 2,000 scanned volumes to create our volume mask pairings. These volumes are loaded in and sent to the lab's GPU in order to perform small degrees of random 3D augmentations, like rotations, shifts, and zooms. These augmented volumes are passed as input to our model for training. The model we use is called a U-Net, which is a convolutional neural network architecture that is best suited for semantic segmentation tasks like this. This model is similar to the traditional convolutional neural network in that it learns based on features as it convolves downwards, but it also learns based on the context of those features as it samples up. The context can be thought of as the location of the features in the image. Since the location of the vertebrae are very similar in spine MRI scans, the U-Net model is the perfect choice since it will learn on the features of the vertebrae as well as their usual position in the spine. In order to retain the feature context learned by the U-Net, the 3D augmentations I mentioned earlier are kept to small degrees. Too large a shift for a single volume would ruin the model's learned context. However, augmentation is required in order to present the model with some variability in the data to help it learn from more examples, like spines with varying degrees of curvature. Having a generalizable model for every person's spine would make the model as accurate as possible and be able to match the accuracy of trained medical professionals. This trained model will be able to accurately segment each vertebrae in a given volume to help radiologists by eliminating the need to manually segment a patient's spine MRI scan sequence. Thank you everyone for watching.